Okay, so in this set of notes, we're going to be continuing our study of ecology, and we're going to focus on the cycling of nutrients. The nutrient cycles are ways that depict how different compounds move through the biosphere between the living parts, which we call the biotic factors, and the non-living parts, which we call the abiotic factors of the environment. We're going to start with the water cycle, also known as the hydrologic cycle. And let's start with a few key terms that you're probably familiar with. First is precipitation. We all know what precipitation is. It's not very common here, but precipitation is when water falls to the earth in familiar forms like rain, snow, sleet, hail, and fog. When it goes the opposite direction, when it goes from the ground up into the air, it's called evaporation. It's a process that can actually purify the water to some degree, because as the water heats up and it gets to a particular temperature, the water escapes into the air and it's just H2O. Percolation is a word that you've probably heard, but maybe not related to the water cycle. Percolation refers to the process in which water that has fallen to the ground moves down into the ground, through the ground, and keeps moving down through the soil until it pools in channels deep in the earth and it becomes groundwater. That process also purifies water, which might sound counterintuitive because you might think that water that's moving through dirt is going to be dirty water, but the soil, as it moves down, actually serves as a filter. Transpiration is a term you may not have heard of before, but transpiration is essentially when plants lose water through their leaves from tiny holes called stomata. This is another water purification process, and you can kind of think of this as plant sweat. Plants don't actually sweat, and it doesn't only occur when they're hot, but you can feel this if, say, it's a hot day and you walk by a field, particularly in our area, a cornfield, and it's just really, the air feels thick and kind of steamy. That's called humidity, and that's because the plants are hot and they are releasing a lot of extra water into the environment. Root uptake is how the plants get the water in the first place. The water, as it seeps into the ground, the roots are modified extensions of the plant that grab as much as they possibly can. Condensation is when water changes from gas to a liquid, and it might not seem like it, but a cloud is actually liquid water, and it's just hanging in the air. And it's thick enough, it's hanging in the air at such a thick point that we actually see it as a cloud. We are really familiar with fog in this particular area, and that's essentially like a cloud on the ground. Finally, we have groundwater, and groundwater is water that's found underground. So as you're thinking about this, hopefully you're kind of imagining the water changing from one form to the next. So let's take a look at this video that shows the water cycle in action. You can feel free to supplement your notes and to kind of give yourself a little visual idea. This video will talk about a couple of different terms, but the idea is still the same. How is it that water is moving through the living and non-living parts of the biosphere?
All the water on Earth today, every drop, is all the water there has ever been on the planet. Fresh water is actually millions of years old, the same water flowing in a continuous loop, falling as rain and snow from clouds to the Earth's surface, running in rivers, pooling in ponds, flowing from faucets, irrigating crops, traveling through plants, generating power, eventually evaporating into the air and condensing into clouds again.
Why is there life on Earth? And the reason there's life on Earth is because Earth has this perfect water cycle.
The water cycle. So simple even small children understand the basics. yet so complex the most advanced earth scientists, hydrologists, geologists, and biogeochemists are studying every part and process.
The water cycle is fascinating. It's something that's around us all the time, and yet we don't really understand it.
How to summarize what is known about the water cycle? With 2 words, flows and stores. The water cycle is a series of flows of water between various water stores or storages. Clouds in the atmosphere.
There's always a little bit of water in the atmosphere. We talk about relative humidity. It's a humid day, it's a dry day. Either way, there's water, sometimes a little, sometimes a lot.
There's a lot of water in the ocean, 70% of all the water on Earth. In the ice sheets and glaciers, 2/3 of all the fresh water on Earth. In the snowpacks atop mountains like the Sierra Nevada. In the Great Lakes, in rivers and streams, in reservoirs and watersheds, in wetlands, in the soil, in and on plants and trees rooted in the soil, and beneath the soil, in water tables and underground aquifers like the Ogallala High Plains, which runs underneath parts of 8 states from South Dakota to Texas. All this storage is temporary. Water in all its forms is always in flux and always moving. And there is a name for every kind of movement in the water cycle, starting with precipitation.
Precipitation is the process of water falling onto the surface of the earth. You can have precipitation in many forms: rain, snow, hail.
Rain is falling water in liquid form. Snow, ice, hail, and sleet are falling water in solid or frozen form. Fog and mist, falling water in gas or vapor form. Precipitation that falls directly onto the oceans becomes part of surface ocean and can be churned by wave and wind action into ocean currents. Rain and snow that falls directly on rivers and streams becomes one part of stream flow. Rain that falls onto land takes a different path to the river, as does the snow and ice that falls and collects on mountaintops when temperatures warm.
When snow melts, some of it runs through the snowpack and goes into small streams, tributaries that feed into large rivers.
What about that precipitation that falls on and over land? Some is intercepted by vegetation, plants and trees.
Like you might imagine someone in the game of football intercepting a pass. These are raindrops trying to come to the ground, and the leaves on the tree intercept them before they hit the ground.
And the precipitation that does hit the ground, it can run off if the ground is hardscape, covered with asphalt or concrete, or if the soil is too wet or saturated to absorb more water, like an over-soaked sponge. Otherwise, precipitation infiltrates the soil surface, percolates into the ground.
Think of it as the water percolating through your coffee grounds in the morning. Gravity continues to pull it downward so it will move through.
Through the topsoil, into spaces between soil and rock particles, down to bedrock and further into fractures, into deep underground aquifers. Even groundwater here is moving sideways or laterally, discharging toward a river, lake, or the sea. Generally, the deeper the flow, the slower the flow.
Some of that fractured water might take a very long time, thousands to millions of years to get out.
And how does water get back out into the atmosphere? It evaporates, is turned from a liquid into a gas or vapor by the heat of the sun.
If you put a bit of water into a bowl and you set it outside on a sunny day, it's going to disappear. It's still water, it's just in the form of a gas rather than the form of a liquid.
Water evaporates from every wet surface, even from wet air. Some rain and snow evaporates into the air while falling. Water evaporates through our respiration and perspiration, and from plants through transpiration. Trans means through or across. Plant roots draw up groundwater.
And plants pull that water up through their stems into their leaves and then release it back out through evapotranspiration.
Evapotranspiration, a spelling bee-worthy term for evaporation from soil and water surfaces, plus transpiration from plants. Evaporated water molecules are tiny enough to flow into the air, mix with smoke and dirt particles in the atmosphere, cool, condense into visible masses of water vapor, clouds. Winds move clouds into colder air, Water droplets collide and merge, grow bigger and heavier until they are so heavy they fall again as rain or snow, sleet or hail. Precipitation, collection, runoff, interception, infiltration, percolation, discharge, transpiration, evaporation, condensation. The water cycle.
Okay, so that was a nice clip of a good water cycle video. So let's get back to our notes here. Sorry about that. So, what would be a simple way that we could draw it? Well, if we kind of start with the basic parts that we were talking about, start with the clouds, which are condensation. We know that plants are part of it, surface water, groundwater, and animals are all part of this cycle. And of course, when we say animals, we should also consider the fact that there's bacteria that are technically involved, and so are fungi and protists as well. So surface water can evaporate into the air, can go the other direction. We call that precipitation. Rain, water, rain, snow, hail, sleet. Surface water can seep into the ground and become groundwater, and we call that percolation. It can go the other direction as well. Of course, animals, just by breathing, we're releasing some water into the air. That's called respiration. It's not one of our primary ways, but we can respire, or we can perspire, which means we sweat, and that's going to return it. Groundwater is also going to be uptaken by plants in their roots. Plants are going to return it into the atmosphere by transpiration. Back there. So this is kind of a drawing version of the water cycle. This is the one that's in your book. Same kind of idea. It has a couple of things added to it. It has runoff coming off of the mountains, but all the same basic parts.